course, and a target. How do you simplify complex fractions? Do y'all know what a complex fraction is? Nope. A complex fraction is when you have fractions within fractions. Sounds like fun. I know y'all love fractions. So fractions within fractions, super fun. So I can't remember of those people at home who said they were coming back to face-to-face. I think a couple of you did. And I think y'all return on Wednesday, if I heard that correctly. But I didn't see any of your names. Well, I guess you're already in my class. So I don't know if they'll keep you in my class or if you'll have a different class. And I can't see you, so I don't know if y'all know the answer to that. But hopefully they'll keep you in the same class. I think the other pre-calculus teacher is currently only e-learning, so, and the other one's Summerlin. So I would think you would still be in here. All right, anyway, example 1. We have 25 divided by x squared, and that is being divided by x plus 2 divided by 25. That looks a little confusing. It's really not a big deal, especially if you're good at finding the least common denominator, okay? So what we want to do, we don't want fractions within fractions. So to get rid of them, we're going to multiply the numerator and denominator of the big fraction by the least common denominator of the individual fractions, okay? So multiply the numerator and the denominator by the LCD of the individual fractions. So in the top, I have one fraction, the denominator is x squared. And the denominator of the big fraction, I have one denominator is 25. So what do you think the least common denominator is? Any guesses? Give me a guess. What do you think the least common denominator is? The numerator of the big fraction, the denominator is x squared. The denominator of, it gets confusing. So in the top fraction, the denominator is x squared. In the bottom fraction, the denominator is 25. We're looking for the least common denominator. X squared times 25, which we would call 25x squared, right? So I'm going to multiply each fraction by 25x squared. Sometimes things will like completely eliminate, they'll reduce completely, and sometimes you can only reduce. So in the top, the fraction in the numerator of the big fraction, when you multiply by 25x squared, that's 25x squared in the numerator, okay? So this x squared is in the denominator. Won't my x squareds cancel out? But the 25s won't because they're both in the numerator, so they won't cancel. And then the denominator of the big fraction, 25 divided by 25 is 1, that cancels out. So your denominators of the individual fractions should completely go away. So in the top, I'm left with 25 times 25, which is 625. And the denominator, I'm left with x plus 2 times x squared. Well, I'm going to put the x squared to the left, x squared, open parentheses, x plus 2. Can I reduce anything? No, if you could, you would. So you're either going to see your answer like that, or they might distribute and get rid of those parentheses in the denominator. Either way is acceptable. That's the answer. Or you could write 625 divided by x cubed plus 2x squared. Either way. That wasn't so bad. It was not so bad. It was not so bad. All right, let's try another one. Example 2. We have x divided by 4. So that's the numerator of the big fraction. And in the denominator, we have 2 more fractions. We have 1/2 plus 1 divided by x. So now I have 3 fractions within the one big fraction. So I have 3 denominators, 2, 4, and x. What do you think the least common denominator would be? Okay, yes, it's 4x, because it can't be 2x because 4 won't divide into 2 evenly. If we use 2x, I'd still have a denominator of, it would reduce, but I'd still have a denominator. You know what I'm saying? But if we use 4x, then each of these little individual denominators will reduce. Oh, I don't think we talked about credit recovery yet. And while I'm thinking about it, did I tell y'all that there's not a credit recovery? Okay, we already talked about that. I still will let you do a Q1 test retake if you made an F or a D for the quarter, but I won't let you do that after this quarter. And then probably this time around, I'll probably start letting y'all do test retakes since there's not a credit recovery, but that'll have to be done immediately, like within a week after the test. Can't do it, 2 months down the road. But for this quarter, since I told you there was a credit recovery, I'll do the Q1 test, and you have to make a 70% or higher to bring your grade up to a C. Now, say you have an F, but you got a C on the Q1 retake, then I'll bring your grade up to a D. That's at least passing. But if you want a C, then you need to show at least 70% mastery on the Q1 test. If you want to do that, you need to see me to schedule. That needs to be done this week, not next week, not the week after, but this week. Okay. And this quarter, let's all get A's and B's. All right. What do you, oh, we already said least common denominator is 4x. So I'm going to multiply every fraction by 4x. So x divided by 4 times 4x, well, those 4's will reduce. The x's won't because they're both in the numerator. 1x times 4x, the x's will cancel or reduce. Now over here, 4x times 1/2. The 4 and the 2, I can reduce them, right? 2 divides into 2 once, 2 divides into 4 twice. So I still have 2 times x times 1 in the numerator, and then I just have a 1 in the denominator. So that leaves me with, in the top, don't forget you still have the x there. So x times x is x squared. In the denominator, the first fraction, I have 2 times x times 1. That's all in the numerator. 2 times x times 1 is 2x. And then there was just a 1 in the denominator. We don't need to write that. Plus, all I have left over here, 1 times 4 is 4. Now, I could factor out a 2 in the denominator, and I would be left with x plus 2. But even if I factor that out, there's nothing that I can reduce. But sometimes if you factor it out, you can reduce. So if you can, you would want to reduce. But either of those answers are actually just fine, because nothing's reducible. Coolio? Does it get harder? Yeah, but it's not too bad. Example 3. I have 1 divided by u, quantity divided by u 16ths plus 2u plus 1, quantity divided by u. What is my least common denominator? 16u. So let's see where I can reduce. In that top fraction, the u's will cancel each other out. Bottom left, 16 divided by 16 is 1. We see it canceled. And then that u and the u will reduce or cancel each other out. So my new numerator, 1 times 16 is 16. The denominator I have, let's see, u times u is u squared. And then over here I have plus 16 times 2u plus 1. Okay, so that denominator, we definitely want to distribute that out and see if we can clean that up a little bit. So I get 16 divided by u squared plus 16 times 2u is 32u plus 16. Now, if I could factor that, I would need two numbers that multiply to get 16, add to get 32. 8 times 2 is 16, 8 plus 2 is 10. 16 times 1 is 16, 16 plus 1 is 17. Can I factor that? No. That's all we can do. Questions on that one? All right, example 4. Am I going too fast, too slow, just right? All right. All right, we have 3 plus 1/4. Quantity divided by 5 minus 1/4. No variables in this one. That's okay, we still do it the same way. We still have fractions within fractions. What is the least common denominator? 4. So even the numbers that are not fractions, I have to multiply everything by the least common denominator. Otherwise, I change the meaning of the problem. So every single fraction, not fraction, every single piece has to be multiplied by 4. So I'm going to cancel out those 4s. And then 4 times 3, nothing cancels out, right? I just multiply. 4 times 3 is 12 plus 1. And then denominator would be 20 minus 1. So that gives me 13/19. Let's do another one. 7 plus 1 divided by x. Quantity divided by 3 minus 1 divided by y. What is your least common denominator? X, y. So I'm going to multiply every term by x, y. So top left, xy times 7 is 7xy plus, let's see, those x's are going to reduce or cancel each other out, right? 1 times y is y all over. 3 times xy is 3xy minus, those y's will cancel, and 1 times x is x. So we could leave it like that, or I do notice my numerator has a GCF of what? Y. So if I factor that out, I have y times open parentheses 7x plus 1 In the denominator, have a GCF of what? X. Factor that out, and you have 3y minus 1. Even when I factor, there's nothing I can cancel or reduce, but if there was, I would do that. So either of these are correct. I always like to show you if there's another way to write your answer, because like when you get your test, if it's multiple choice, I want you to be familiar, because sometimes they'll put stuff factored and sometimes they won't. So you got to remember, factor when you can to see if you can reduce anything. All right, you ready to step it up a little? Okay. So we have x squared divided by x minus 2. Quantity divided by 3x divided by x squared minus 4. Now, before you say that the LCD is x minus 2 times x squared minus 4, that's a common denominator, but it's not the least common denominator. And I know that because x squared minus 4, that's a difference of 2 squares. That can be factored, right? So let's factor that first before we determine the LCD. So in the numerator of the big fraction, there's nothing that I can factor. So I'm just going to rewrite it. The denominator of the big fraction, I have 3x divided by a perfect square minus a perfect square. Yes, we could do T-chart divide and slide on that, but I taught y'all a shortcut. If you have a perfect square minus a perfect square, to factor it, short and sweet. Make 2 sets of parentheses. Put a plus in the middle of one set and a minus in the middle of the other. The first term of each set of parentheses is the square root of the first term. What is the square root of x squared? X. The second term in each set is the square root of the second term. Don't worry about the minus sign. Just what's the square root of 4? 2. Now, my denominators, I have an x minus 2, and I have an x plus 2 and x minus 2. Think about when we were adding and subtracting fractions. What would my LCD be? X plus 2 and x minus 2. So in the numerator of the big fraction, the x minus 2's cancel. The denominator of the big fraction, the x plus 2 and the x minus 2 cancel. And we just write what's left. So in the numerator, I have x squared times the quantity of x plus 2 over, and the denominator, all I have is a 3x. Okay, hey, before I distribute that numerator, x squared is a monomial, 3x is a monomial. Can I just reduce? It doesn't have to be all or nothing for a monomial, right? I can reduce that because x squared divided by x is just x, right? So x squared divided by x is x divided by x is 1, we just say it cancels. So I can reduce that. So I have left x times x plus 2 over 3, or I could say x squared plus 2x quantity divided by 3. Always reduce when you can. Julio? Let's try this one. 5 divided by x plus 5 minus x plus 5 quantity divided by 25. And that whole thing is being divided by x plus 5 divided by 5. What do you think the LCD is? No, 25 is part of it, and x plus 5. Because x plus 5 is a binomial, right? So that 5 and the 25, that can't go together. So your LCD is a 25 times x plus 5. So top left, the x plus 5s cancel. Top right, the 25s cancel. And then on the bottom, nothing, the 25 I can only reduce. 25 divided by 5 is 5. So this one's going to be kind of messy. So top left, all I have left is 25 times 5, which is 125. Minus, let's see, I have x plus 5 times x plus 5. So I'll go back and multiply that out in a minute. And in the denominator, I have x plus 5 times x plus 5. So 5 times x plus 5 times x plus 5. Okay, so look, I can't cancel those x plus 5s out right now because of that 125 minus x plus 5 times x plus 5. If that was only factors up there and that was all being multiplied together, I could cancel those out, but they're not. So I need to multiply everything out in the numerator and then combine the like term of 125 and then see if I can factor it and if anything cancels. But at this point, if you cancel it out, you're not going to get the right answer. Okay, so let me multiply all this out. So I have 125 minus, and I'm not just subtracting the first term, I'm subtracting the whole thing. So I'm going to have to distribute that negative at the end. So let's see, I have x squared plus 5x plus 5x. I'm just doing it in my head is plus 10x, and 5 plus 5 is 25. So now let me distribute that negative. So I have 125 minus x squared minus 10x minus 25. Combining like terms, 125 minus 25 is 120. In standard form, that would be negative x squared minus 10x plus 120 all over 5 times x plus 5 times x plus 5. Now look, in the numerator, you know when your leading coefficient's negative, you don't want that. You always factor that out, right? So that would be negative, open parentheses, x squared plus 10x minus 120. Yeah. Oh, yeah. Sorry. Thank you. Oopsie. Now, that numerator, that's a quadratic. So if I set up the t-chart and divided slide, I would need two numbers that multiply together to give me negative 100 and add to give me 10. So if I did negative 10 times 10, that's negative 100. Negative 10 plus 10 is 0. That won't work. If I did like 25 times negative 4, I get negative 100, but 25 minus 4 is 21. That won't work. Any combination of 50 and 2 is not going to work. 20 and 5, that's not going to work. Am I missing anything? Anything else I can multiply together to get 100? I did 10 and 10. 101 is not going to work. 101, 50 and 2, 25 and 4, 20 and 5. Am I missing any factors of 100? I don't think so. So it's not factorable. If it was, I would factor it and see if there was anything that would cancel out, but it won't. So that would be my answer. And I didn't ask you for excluded values, but if I did, what would the excluded value be? Negative 5. Okay, I think I have one more for you. And then I'm not going to give you homework today. Tomorrow we'll have an assignment. Anybody have questions on this one? Still copying? Anything of the sort? Okay. All right, we have 3 divided by x plus 1 minus x plus 1 divided by 3x plus 12 and all of that is being divided by 9 divided by x plus 4. So x plus 1 times x plus 4 times 3x plus 12 is a common denominator, but it is not the least common denominator. And I know that because 3x plus 12 can be factored. And when I factor that, I'm going to get 3 times x plus 4. And so we don't need to include both x plus 4s. I mean, if we do, it's just going to be more reducing in the end. So that's going to be factored. I'm going to rewrite this whole thing just to factor that out because I like to show my work. Because you should always show your work in math class. Does everybody understand that? I just factored out 3 out of x plus 12. The 3 is still there, did not go away. So what in the world is my least common denominator? I need a 3, right? The only monomial is a 3. So 3, I need a 3. And an x plus 4 and an x plus 1. Good. All right, so I'm going to cancel what I can. So top left, I have 3 times x plus 4 times 3. So I'm going to go ahead and do 3 times 3 is 9, and then times x plus 4, and I'll come back and distribute that later. Minus, I have x plus 1 times x plus 1. And I'll distribute that negative once I multiply those out. All over, I have a 9 times 3 times x plus 1. So I'm going to call that 27 times x plus 1. Again, until the numerator is all just factors, I can't cancel the x plus 1s out, okay? That numerator, I've got to multiply all that out, recombine like terms, see if anything can be factored before I can cancel or reduce anything. The 9 and the 27, well, they'll end up being part of in the problem unless they're a GCF of the whole thing. So don't cancel those out yet either, okay? So I'm going to multiply this whole numerator. The denominator is already factors, it's factors only. So I'm not going to distribute that back out, but the numerator, I got to multiply all this out, combine like terms, and then try to factor, okay? So I get 9x plus 36 minus, I'm going to multiply all that out before I distribute the negative. So it's x squared, and then 1x plus 1x is 2x plus 1. Now I'm going to distribute that negative. So I get 9x plus 36 minus x squared minus 2x minus 1. In the numerator, I'm going to combine like terms and put it in standard form. So negative x squared would be my first term, nothing to combine it with. 9x minus 2x gives me a positive 7x. And 36 minus 1 is a positive 35. I don't have a GCF in the numerator, but I do have a leading coefficient that's negative. So let's factor that out. In that numerator, there's a quadratic. I would need two numbers that multiply together to give me negative 35 and add to get negative 7. Well, I know, let's see, negative 5 times 7 is negative 35, but negative 5 plus 7 is 2. And if I change the signs, that doesn't work. My only other combination would be 35 and 1, or negative 35 and 1, or 1 and negative 35, and that's not going to add to give me negative 7. And 35 doesn't have any other factors, right? So it's not factorable. So I can't do anything else with this. So I could leave it like this, or I could multiply it out. Either way, sufficient. Julio? Well, so we finished a lot faster than we should have. But we are so far ahead of my other class because we spend so much time together. I hate to keep getting further and further ahead. Do you want to do a try one on your own? Or since we're so far ahead, just give you a break. Okay, how did I know you're going to say that? So everybody at home, you can go ahead and log off. Go ahead and eat lunch. I'm going to go ahead and stop the video so that I can get it uploaded onto Schoology. No assignment today. Tomorrow we'll have an assignment. And hold on, let me see what my chat is. What was the answer to number 3? The answer to number 3, let me put it back up. If you're still here, Yasmin. The answer to number 3 was 16 divided by u squared plus 32u plus 16. You're welcome. Anybody else have any questions? All right, y'all can log off. I'm not going to say anything else. I promise. I'm going to stop the video. Okay, bye.